Okay, we're going to do pages 596 through 601, problems 71, 83, 87, 89, 95, and 102. It is after school on Monday, and I have one student here with me. 71. It says, one-sided test. Oh, Alexis is coming in too. Suppose you carry out a significance test of null. Your HO is mu equals 5 versus your HA, which is the mean is less than 5, based on a sample of size n equals 20, and obtain t equals negative 1.81. This is in your text, if you read it, something I was avoiding showing you guys. We could look at our t-table and try to figure out, since they gave us a t-score, and we basically need the p-value, could we look that up? Well, we know n is 20. So from this problem, wait, are you doing statistics? Do statistics.
No.
Why not?
Because I'm studying for the test tomorrow.
Oh, okay. 71, n equals 20, which implies that the degrees of freedom is 19. If this were a multiple choice question, it's possible they would give us a range for our p-value. So I look on my z-score table, t-table, somebody wrote on this one, shame on you somebody. I see 19, and I'm looking for a t-value of negative 1.81. It doesn't matter if it's negative or positive, we'll just look at the positive end, 1.81, and I see that it's really close to this one right here, but slightly below it or above it, t-wise. If you look at your tail probability, you see that it's in between 0.05 and 0.025. If you're doing Math Excel, you may be able to guesstimate what it is unless they provide you with a range. Your p-value should fall between 0.05 and 0.025, but it should be closer to 0.05. Now, you can do this with technology in your calculator. If you hit the second VARS button, remember back when we did normal CDF, you're looking for T-CDF. That's for a t-distribution, cumulative t-distribution. So you're going to put in your low, the one on the left, comma, the one on the right, and because we're talking t-distribution, you need one more number there, and that's your degrees of freedom. So, in T-CDF, the number on the left, since we're talking about negative 1.81 for your t-score, or t-value they called it. Oh, was it 1 point? Yeah, negative 1.81, and we want to shade below. Then we're going to something extreme over here. Now in the book it says use negative 100. This isn't that high, so you don't have to use negative 100. It doesn't matter if you do. Negative 5 is fine, negative 10 is fine, whatever you want to plug in here. But I'm going to do T-CDF, negative something extreme. I'm going to go with negative 10, negative 1.81, comma, 19, and it should give me my p-value. So when I do that in the calculator, I get, clear that out, second VARS T-CDF. Ooh, look, there's an inverse T too. Could use that as well. And negative 10, comma, negative 1.81, comma, 19, enter. I get 0.043, which is what was in the back of the book. So for part A, it wanted to know your p-value. It's 0.043, which is less than 0.05. What alpha did they want? It said, what conclusion would you draw at the 5% significance level or at the 1% significance level? For part A, it said, use table B. Well, they really didn't ask for the actual p-value. So based on the table, I could have said that we would reject at the 0.05 level, since our p-value is between 0.05 and 0.025, but fail to reject at the 0.01 level, since it's more than 0.01. And I could have just used that much information and been done. Yes?
Okay, so I'm asking a question about number 83. How do you determine if the confidence interval includes something if you only have like two numbers? You get the null hypothesis and this 0.06, I don't know where it came from. So,
0.06 is your p-value.
the two-
So, for a two-sided test, your tail end of your probability, Adam's asking about number 83, the tail end of your probability for two-sided is 0.03 on either end.
oh, so it doesn't fall within 95% confidence.
Right.
It can't fall.
Well,
within-
it's inside your 95% confidence interval. Because for 95, this in the middle would be 0.94.
So it does fall within the.
Yep.
confidence
It does fall within the interval. But does the 90% confidence interval include the 10? Here's 90. 0.9. You should have 0.05 on either end.
interval. It doesn't. It doesn't.
Right.
So what is it? What does that mean in context? Like,
In context, you would reject at this is alpha equal to 0.05. In context, the 95% confidence interval would contain the 10, but the 90% confidence interval would not.
so if you wanted a 90% confidence interval, you would fail to reject.
For a 95% confidence interval, if it contains the value, then you fail to reject.
Because it's still
Contains.
within the 95% confidence.
Right. But for the 90% confidence interval,
You would be able to reject with 90% confidence.
right,
Or-
because your p-value is smaller than 0.10.
Oh, so the smaller the value gets, the more confidence you can reject it with.
Yes.
Okay, there you go.
Okay, back to 71. 0.043, the p-value is less than alpha equal to 0.05, so you would reject the HO. For the second part, the p-value is greater than alpha equal to 0.01, so you would fail to reject the HO. That would all be part A. Part B wants to know if you changed it to a two-sided alternative. Well, we learned in class today, if you're in 8A section, that looking at the two-sided test just causes you to multiply your p-value by 2. So 2 times your p-value, which implies that you have 2 times 0.043, so your p-value is 0.086. So if your p-value is that high, you would fail to reject at 0.05 because it's greater than 0.05, and of course it is greater than 0.01. So fail to reject at alpha equal to 0.05 and alpha equal to 0.01 since the p-value is greater than both. So that wraps up 71. Adam was just asking about 83. Alexis, you have a question? You're trying to what? You're trying to learn? Why don't you take out a piece of paper and do the book prompts? And then we'll do trig after. I promise. I'll stay till 4, just for you. You can't? What time's practice? 3? Okay, I'll do this for 7 more minutes, and then I'll cut it off. 83. So, the p-value for a two-sided test of the null hypothesis was that the HO was 10, or the mean was 10, and the p-value is 0.06. So they already ran the test, and that's their p-value. For 95% confidence for mu, include 10, why or why not. If you did, it's a two-sided test, so for 95% confidence interval, when your alternative is two-sided, mu not equal to 10, you still compare your p-value for 95%. You have to add the two tails. This is 0.025 and this is 0.025. So your alpha level that compares with the 95% confidence interval is 0.05 because it's 1 minus 0.95 equals 0.05. And your alpha level is half of that. No, I'm messing up big time right now. So alpha should equal 1 minus 0.95, which is 0.05, even though it was divided on both ends. Our p-value was 0.06, which is greater than 0.05. So for part A, the 95% confidence interval does contain 10. If we look back up at the 94% confidence interval I drew, that's smaller, narrower than 0.95. So 0.03 is on either end, and since 0.94 can fit within the 0.95, that means 10 must be in it. It's on the edge of it, but it must be in it. However, when you switch to a 90% confidence interval, now you have more shaded on either end. This is related to an alpha level of 0.10 because you're adding up both ends. So if your alpha equals 0.10 and your p-value is 0.06, you would reject the null, which means that 10 is not in the interval. The mu is not in the interval. That was really messy. If I have to, I'll explain it during class. Next problem, number 87. Adam, how you doing over there?
Okay.
87, clean slate. Oh, we were talking about tomatoes again. Lovely. Researchers suspect that variety A tomato plants have a higher average yield than variety B. To find out, researchers randomly select 10 variety A, 10 variety B tomato plants, and the researchers divide in half each of the 10 small plots of land in different locations. For each plot, a coin toss determines which half of the plot gets a variety A plant and which plot gets variety B. After harvest, they compare the yield in pounds for the plants at each location. The 10 differences in yield, variety A, variety B, are recorded. A graph of the differences looks roughly symmetric and single peaked with no outliers. Okay, stop. All this stuff, yada, 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 is telling you your sample size is 10 and you're looking at differences and that the graph is roughly symmetric. They had random assignment in there, so both conditions are met. They have a paired t-test on the differences. You have a t-value 1.295 and a p-value 0.1138. That p-value is high. So that would mean that you would fail to reject your null. Part A, state appropriate hypotheses for the paired t-test. Be sure to define your parameter. So remember, this might not look like exactly what the book wanted, but it's what all you need for the AP exam. This is number 87. Part A, I'm going to define mu sub d as my parameter, and that is the mean of the differences in pounds for variety A plant minus variety B. Hi, Miss Roberts.
I'm sorry. Thank you for letting
You're
me know.
fine. I'm just recording right now. That's why they're quiet. So we have that checked. Now we just have to write the HO, the HO, whatever you want to call it. Everything's always wonderful in HO land. So the mu, whatever it is, will always equal something. In this case, we want to say that there's no difference. There's no difference in the variety of the plants. They're all the same. Nobody's different. Everyone's equal. The alternative is that, was one better than the other? I'm rereading really quick. After harvest, they compare the researchers suspect the variety A have a higher average yield. That just means that they weigh more, I believe. So the mean difference, how did we subtract it? Did they tell us how they subtracted variety A? They did variety A minus variety B. So if we took all of our A's, which are supposed to be higher, and subtracted all the B's, we should end up with a positive difference. So that mu sub D should be greater than 0. Part B. What are the degrees of freedom for the paired t-test? That's just going to be your number of plants, which is 10, minus 1, which is 9. Interpret the p-value in context. Go back to the writing the statistics way, language, whatever I called it. If the null hypothesis is true, if the HO is true, then there is a blank % chance. Did they tell us our p-value? Yep, they did. 11.38. 11.38% chance of obtaining. They didn't tell us what our actual values are. Obtaining the sample results, because they didn't tell us what they were, in the variety A tomato plant yield minus variety B tomato plant yield. I'm sure there's a quicker way to say that. What conclusions should the researchers draw? The researchers should, Adam, what should they do with the p-value of 11 point?
Still reading.
Oh.
There's 11.3 chance of obtaining sample results in the variety A tomato plant. What does it mean, chance of obtaining the sample result?
They didn't tell us what our sample results were. If they had told us that the differences were an average of 2 pounds from variety A minus variety B.
And there would be like an 11.38% chance of getting that?
Yes, but they didn't tell us what our results were. So I just left it written the way that they said it.
Okay.
And with a p-value of 11.38 or 0.1138, the researchers should fail to reject the HO since p-value equal to 0.1138 is greater than alpha equal to 0.05. The researchers, do not have enough evidence to claim, I'm going back up to the beginning of the problem where it says researchers suspect that variety A tomato plants have a higher average yield than variety B. So they don't have enough evidence to claim that variety A tomato plants have a higher average yield than variety B tomato plants. Part D wants a type 1 error. Describe a type 1 error and a type 2 error in the setting. Which mistake could researchers have made based on your answer in Part C? Type 1 error is you reject the null and you're wrong. So type 1 error, the researchers reject the HO and say they have evidence. There's too much writing on this problem, I apologize. They have evidence that variety A plant has a higher average yield than variety B, when actually there is not a difference between the two. Between variety A and variety B. Type 2 error, you would fail to reject just as we did above and conclude that a variety A tomato plants we don't have enough evidence to claim. So type 2 error, this is the one the researchers could have made. And it has the same conclusion as before. So they get the conclusion from Part C. But find out they're wrong. I could say more in context, but that just took one whole page, and I'm sure you guys are feeling the same way. How you doing, Adam?
I'm stuck on 189 and 97 and 100 and 101.
Oh, so you skipped ahead.
Well, I mean, I don't know how to do 89, so I just tried to do whatever I knew.
89. Says, the power of tomatoes, refer to exercise 87. Explain 2 ways that the researchers could have increased the power of the test to detect mu equal to 0.5. What is one way to make things better? What? What'd you say, Alexis? Okay, she said it wasn't appropriate. To increase power, what should you always do to make things better? It costs more money.
You can make more people take your test.
Okay, so we're talking tomato plants. You could,
Get a larger tomato plant.
to increase power, you could, number one, increase the number of tomato plants, the number of tomato plants for variety A and variety B.
But you have to increase it to 50%. How do you do that?
No. Power is the ability to reject your null and be right about it.
Yeah,
So
but
they're
once you
saying,
increase it to 0.5. How do you do that?
nope. They want us to explain two ways the researchers could have increased the power of the test to detect that mu equals 0.5.
So they give you that number for no reason?
That's what the parameter was, the HO. So they want to increase the power, which is to reject the HO of mu equaling 0.5.
Increase tomatoes for both varieties.
And then the other thing we could do, what would make it more likely to reject your null? If we have a p-value of 0.1138, what could you do with your alpha?
Oh, you can make it larger.
Yeah. Change alpha equal to, it is cheating, but that's statistics, to 0.15 since the p-value, was this the right problem, was 0.1138? Or am I on a different problem? Yep, 0.1138, since the p-value equaled 0.1138. That is so cheating. What's the next question?
95, but I already did that one, but if you want to do it.
95. The reason we use T procedures instead of Z procedures when carrying out a test about population mean is we don't have the population standard deviation. Is that what you wrote?
Mm-hmm.
It should be, what number, what letter is that?
That's
B.
That's B.
And if you want, you can always look in your formula packet, and the formulas they give you in that crazy looking box, these are for Z. We don't have sigma, we have S. That's what we've been using because we don't have this. So that's for Z, which I keep telling you guys, mean Mr. T, just use the mean. So it's got to definitely be B. Number, did we do all of them? 96. You are testing the null that mu equals 10 against mu is less than 10. Simple random sample of 20. You got a t-score and a p-value. And we look on the table. And look at the range. I promised you they give you a range. So you flip to the table. You just have to look all this stuff up. It's like, can you read the table? 20 is our sample size. So our degrees of freedom is, what's your degrees of freedom? 19. Your t-score is negative 2.25. Ignore the negative. Just look for 2.25. And I see that it's in between 0.01 and 0.02. Is that what you got?
Yeah.
0.02 and 0.01 is your p-value, that tail
Right.
probability.
97.
So A.
The thing is, I can't find any of these things in 197.
96 is A.
So there's 15 observations here, 14. And then...
What values of the test statistic are statistically significant? But they said not equal to 10. So your p-value for the 0.005 level,
It should double.
so 0.5. So we're talking a 99% confidence interval.
99.8.
99. Isn't it?
No.
If you have 0.005 on either end, so you have a 0.5% on either end of your confidence interval.
Wait, no, it's 3 zeros and a 5.
Yeah, but if you move the decimal back for 97, you have 0.5%. Actually, no, it's half of 0.5%, isn't it?
Yes, it is.
That's what you're telling me. So what's that? 0.25%? Is that right?
No, it should be if it's two-sided, it should be 0.001. Because you doubled it. Yeah. But in such
1
case, that
minus
would make the answer wrong.
0.005 divided by 2. We have our alpha and it's two-sided. Getting all confused. It's a two-sided test and our alpha level is 0.005. Now your alpha, your p-value is multiplied by 2. But your alpha, this is half of your alpha. And this is half of your alpha. So if your alpha adds up to 0.5%, then this confidence interval is 99.5. Is that what you said originally?
I don't know.
So that confidence interval should be 99.5. Why do we need that?
So it should be D then? Yes.
We're looking for the t statistic, 0.995. Do we know our sample size? 15.
It is D.
And I have 3.286. Nope. 14, 3.326. I didn't subtract 1. Your degrees of freedom is 15 minus 1, which is 14. So when you look it up on the table, we have 99.5, and we're going all the way up, up, up to where it has 14, 3.326, that it's either negative or positive. So as Adam just said, yes, the answer should be D. And then 98, after checking that conditions are met, you perform a significance test that the mean is 1 versus the mean not equal to 1. You obtain a p-value of 0.022. Which of the following must be true? So your p-value is 0.022, and we're comparing that to a certain alpha level. I'm looking down, they have all these confidence intervals. If your p-value is 0.022, they're asking, is any of these confidence intervals containing that value 1? So again, we have to go back to what we were just using with the confidence intervals and a p-value of 0.022. If your p-value for two-sided, this is 98, this little end and this little end, if the p-value was 0.022, you have to divide that amount by 2 for either tail of that confidence interval. So 0.022 divided by 2, you get that this little end is 0.011 and that this little end is 0.011. So the confidence interval would be a 97.8 if we use this p-value of 0.022. So that is larger than your 95% confidence interval. So for 95, I would reject HO. And for 99, I would fail to reject. So now reading, you're all done?
Yes.
You're awesome. 99, we would fail to reject. And it says, don't know why they're asking if we would include 0. Why are they asking if we would include 0? That's interesting. After checking, thanks. 95% confidence interval for mu will include the value 1. No. The 99% confidence interval will contain the value 1. I don't know what's going on with B and D and why they suddenly threw in a value of 0. But it should be Z, or C, for 98. And then 99. They're reading through the problem, and we're at 35 minutes. And that's a lot of time to be doing this homework assignment. So I'm going to cut us off. And if you have questions on 99, 100, 101, or 102 in class, then please ask before your Chapter 9 quiz. Thank you.